All right, we're going to be looking at our lesson 5 practice problems here, and we have some really challenging questions that I don't actually think that the lesson set us up for. So here we have a restaurant offers free delivery. No, that doesn't say free delivery. Restaurant offers delivery for pizzas for a fee. Wow, Mr. Sinclair can't read. Okay, so fee. So I need to add a fee to the price of pizzas. One customer pays 25 to have 2 pizzas delivered. Another customer pays $58 to have 5 pizzas. So let's go ahead and put this into a table here where I have pizza and I have my money getting tracked right here. So if I have 2 pizzas delivered, it costs me 25 bucks. If I have 5 pizzas delivered, it cost me 58 bucks. Now, I think what the lesson today taught us nicely is that when I divide these two, I'm going to get a failed proportionality. 25 divided by 2 is 12.5, whereas 58 divided by 5 is 11.6. And so I'm a little bit out of luck with what we've been doing previously. However, we should be able to find the slope, the change in my x and the change in my y. So I'd have 58 minus 25 here. And let's do that. 58 minus 25. I get $33. So $33 there. And then my change would be 3 pizzas here. So I know that my slope is going to end up being $33 divided by 3 pizzas. If I go ahead and divide that out, 33 divided by 3, that's going to give me 11 bucks. $11 per pizza. Now we're tasked, how do we find the fee? So we have to imagine that we ordered 2 pizzas. If I ordered 2 pizzas, that should be 2 times 11. So I take 2 times my 11, and that's only 22 bucks. What's missing is the fee. So I need to say plus my fee. Well, you can see your fee is going to be 3 bucks. But I'm just curious if that's the same for 58. So if I take 5 times 11, that's 55. Is 55 plus 3 also 58? Yes. So I need to get to this charge that I had, which was my 25 and my 58. And it just so happens that that must mean that my fee is 3 bucks. Okay, so now we have fully analyzed this setup. Now we can actually read what the question is. So the actual question it wants me to analyze here is how many pizzas are delivered to a customer who paid $80. Well, that $80 includes the fee. So if I'm going to take that up here, I'd have to have my 80 bucks. I should take my fee out of that. So my fee would be minus 3 bucks. That leaves me $77 just for pizza. Well, if I'm paying 11 bucks per pizza, that's going to be 7 pizzas. And we could prove that by just taking this 11 that we had previously, take 77 divided by 11, and that's going to be 7 pizzas. So this guy must have ordered 7 pizzas. It's a pizza for every day of the week if you have a refrigerator. All right, question 2, much easier. Question 2 is to paint a house. A painting company charges a flat rate of $500. So I have a flat rate of $500 plus $50 for each. Ooh, this is code for slope. Okay, that's code for slope. Plus $50 for each hour of labor. Okay, so how much would the painting company charge to paint a house that needs 20 hours of labor and a house that needs 50. So let's first set it up. 20 hours and 50 hours. So 20 hours, I'm still going to have to pay my fee, my flat rate of 500. So I have to pay my 500 bucks. And for this guy, I also have to pay my 500 bucks. Now, after that, I need to pay the amount for each hour. And it says it is 50 bucks per hour. So I'd have to pay $50 per hour times the number of hours I'm working. So here it would be times 20, and here it would be times 50. These would be my totals that I am running here. So I believe this is 1,000, and that would be 25,000. So let's double check, or 2,500. So 500 plus 50 parentheses 20. Okay, so I have 15,000 or 1,500 here. So that's the money I have to pay if they work for 20 hours. If they work for 50 hours, I change this over to a 50, and that would be 3,000. Now, I've been obsessed with tables today, so let's go ahead and put this into a table. So if I want to track my hours and my money in a table here, I could put 20 hours, and I put my money over here, 1,500, and I put my 50 hours, and I put my money, 3,000, over there. All right, now I am a little suspicious that I'm fully set up for my question down here. Draw a line representing the relationship between X, the number of hours it takes the painting company to finish the house, and Y, the total cost of painting. So X is my hours, Y is my cost. Label the 2 points. Okay, so I'm going to put these 2 points on that graph here. So let's go ahead and find where I have 20 and where I have 15. 1,500 right there. And so I'm going to draw those two together. Where does that come together? It comes together right here. So that must be my point 20, comma 1,500. And then let's do my 50 and 3,000. So my 50 and my 3,000 are there. Let's see where those guys meet. Bring this across, bring this up. Okay, so those guys meet right here. And I will have 50, comma 3,000. All right. And then they want a line representing this. They're calling for a line representing. So I can just go ahead and connect these with a ruler. Now, if we did this nicely, we're going to see something really cool with where this touches the y-axis. So here's my line coming through. And I want us to take a moment here to look at where does it touch here. This number is 500. So for 0 hours of work, I still have to pay $500. And that makes sense. That is in my story. This point is in my story up here as a flat rate. I like to call this as the start. Okay. And then it has a question down here. I'll zoom down a little bit. Find the slope of the line. It says, find the slope of the line. What's the meaning of the slope in this context? So slope of this line, I can do rise and run here. All right, I could calculate my rise. I can calculate my run. If you like to do that here, you can. Or you could calculate your rise and run right here. So this would be my rise, and this would be my run. Okay, and I'll let you go ahead and calculate out those numbers yourself, show your work. Okay, so if you're going to do this, I would have my rise over my run. And that's going to be something minus something up here over something minus something down here. And that my rise is counting my dollars. And my run is counting my hours. And actually, we know what the answer should be based off of just the question up here because we were tipped off by this word each. So I have $50 for each hour of labor. So when you calculate this and you show your work of your two things getting subtracted and your two things getting subtracted, you should get an answer that is $50 per 1 hour. Okay, so that's $50 per hour. We have Kitty Cat coming to say hi. All right, we're ready for the next page. Okay. Oh, cat's in the way. All right, Kitty. Okay, so Tyler and Elena are on a cross-country team. Tyler's distances and times for training are shown on the graph. So go ahead and label this as Tyler. And Elena is shown down here. So this is Elena. Now, whenever I see a graph, I immediately want to know my slope right away. I'm going to find myself two nice points on here. So I have a point right there and a point right there. Kitty's still behind me? Yes. Okay. So here is my rise. And here's my run. Now this rise and run is shockingly confusing because I initially thought my rise was just 8. It looked like my rise was 8, looked like my run was 1. And when I look at it, it's 8 minutes, and then it's 1 mile. So I thought my slope was going to be 8 divided by 1. But I think that this point here is not at 8. It's right here. So I have to find what these are actually jumping by. I have 1, 2, 3, 4, 5, 6. So like 3 of them, this would be 1, 1, 2, 3. This would be 3. 1, 2, 3. This would be 5. 1, 2, 3, 7. So 1, 2, 3. This guy right here is 9. So this is 8 and 1/3, right? Because I have 1, 2, 3 jumps between 8, and I'm on one of them here. So this is 8 and 1/3. So it's actually 8 and 1/3 minute. When I put this into a calculator, that would be 8.3333333 minutes. And that's per 1 mile, per 1 mile. So this is the slope of Tyler's graph. This is how long it takes him 8.333 minutes to run 1 mile. And if you look at Elena's distances and time for a training run are given by the equation y equals 8.5x, where x represents the distance in miles and y represents the distance in minutes. So I'm going to replace these things with what they are. So this is going to be, I'm going to rewrite this, y equals 8.5x. And here, this is going to be minutes equals 8.5 times miles. So you can kind of see that Elena is running each mile in 8.5 minutes, because if I put in 1 mile, if I plug in 1 mile right here, I would get 8.5 times 1, and that would give me 8.5 minutes here. Okay, so plugging 1 mile in gives me 8.5 minutes. So I know each person's pace now. So Elena equals 8.5 minutes per mile. And then I know Tyler equals 8.33333 repeating minutes per mile. Who ran faster? Okay, so if they're both running a mile, who took less time? Tyler took less time. So Tyler took less time to run 1 mile. So he is fastest. Oh, there we go. All right, let's finish this off with question number 4. Write an equation for the line. Well, I didn't even want to read that. I just wanted to find a slope right away off my line. I'm going to pick 2 nice points. I'm going to pick this one point. When I practiced this one, I picked, I think this point. You could pick this point, or there's a ton of different points here, which makes me it looks like it's going up 1 and over 2, up 1 and over 2. I'm going to go ahead and just go like this. So I'm going up 2 and over 4. Okay. Now, also, in order to find an equation of a line, it's helpful to know what my ordered pairs are. So I have a 5 and a 2, and I have a 6 and a 7. Okay. So right off the bat, I should know that my rise divided by my run is going to be 2 divided by 4, or 0.5. So this is my slope. But we're going to go a little redundant here. We're going to do this work a different way with a table. So I'm going to run my x and y. I'm going to put those 2 points in that I know. So I have 2, 5, and I have 6, 7. And then I'm going to put an x and a y here so we can track all of my changes here. So this is going to be a rise equals 2. This is a run equals 4. And here my rise is going to be y minus 7. And here my run is going to be x minus 6. That's how I like to set these up. So then if I want to just write it as rise divided by run, hey, we can just set all these in here. So I have 2 divided by 4 is equal to this rise, y minus 7 over x minus 6. And this right here has an equal sign. It's an equation. Okay? So I have my equation right there. This is the equation of that line. Now, of course, you could simplify things. Like, we already knew that my slope was actually 0.5, so I could put 0.5 in there. Could put a 1/2 in there, depending on what you want to do with your slope. Hopefully that was helpful. I know the pizza problem, I thought was a little challenging at the beginning here, but hopefully this review can help you. All right, math is good.